These are almost like puzzles. They give you various pieces of a triangle, and they give you some trig ratios as clues, and you just have to solve it all out. So we're finding secant of arctangent of 3 pi over 4. The best way to start these is just make a triangle. Put your angle wherever you want. I usually just go ahead and put a right triangle there, put an angle right there, and then use your trig ratio to set it up the way it's appropriate. So if we're talking about arctangent of a ratio, then that means, and I'm just going to put this kind of above it, tangent of some angle is 3 over 4. So tangent of this angle would be opposite over adjacent. And if you do Pythagorean theorem, or you recognize the Pythagorean triple, that hypotenuse has to be 5. We'll need that in a minute because we're going to do secant. So I'll go ahead and fill that in. So arctangent of 3 over 4, arctangent of 3 over 4, I'm just going to call that theta. If you look at the triangle the way I've set up, that would make it true. And if you think about the way I wrote this statement up here, if you solve for theta, you get arctangent of 3 pi over 4, sorry, just 3/4. So that's what I would do. I think this is the best approach. Just make up a variable theta, or call it whatever angle you want to call it, but it is an angle. All right, and then secant of the angle. Now, personally, I have trouble thinking it's secant, so the way I think about it, I think, all right, secant goes with cosine. So that's 1 over cosine of the angle. Or once I know cosine, just flip it over. So however you want to think about it. But cosine of this angle will be 4 over 5. Secant's going to flip it over, so it's 5/4. And that's your final answer. All right, similar ratios, different triangle to set up. So secant of arctangent of x plus 3. We'll start with my triangle the same way. This time it's arctangent of x plus 3, and that's it. So it might feel like, wait a minute, it's not a ratio, but it is, because you can put anything over top of 1. So this is x plus 3, and this is 1. To solve this one, we'll need to do Pythagorean theorem for sure. So you've got these two sides, x plus 3 squared plus 1 squared is going to equal your hypotenuse squared. All right, x squared plus 6x plus 9 plus 1 is hypotenuse squared. X squared plus 6x plus 10 is my hypotenuse squared. So this side right here, I erase h and replace it. It's going to be square root x squared plus 6x plus 10. Kind of awkward, but that's what it comes out to be. Right, well, that means that I'm going to end up taking secant of the angle, because again, if arctangent is this ratio, then that's your angle right here. You could rewrite that. So for this angle, secant, right, secant comes from cosine. Cosine's adjacent over hypotenuse, so secant's hypotenuse over adjacent. The answer to this is square root x squared plus 6x plus 10. If you're one of those people that gets in the mindset of, oh, it's a trinomial, I need to factor, you only factor if you're being told to factor or if you're solving for something. And we're just figuring out what that ratio has to be. We're not solving for x, so don't factor just because it's a trinomial. That's an easy trap to fall into. Last example for today, cotangent of arcsine of negative 3 over 5. I'm going to kind of go with that logic again where I say, all right, well, sine of the angle has to be negative 3/5. Now we got to think about that interval for arcsine, where it exists. Well, it's negative pi over 2 to positive pi over 2. So we're looking at something in the fourth quadrant here. I say it that way because negative pi over 2, that's down in the fourth quadrant. You sweep through the fourth quadrant to get there. So I need when I set my triangle up, I'm going to do it that way. I am going to be careful to put it down there this time. So if I'm thinking about this being part of a unit circle, that triangle's down in the fourth quadrant. 5 is the hypotenuse, negative 3 is the opposite side. It's really the same triangle I've been using. You can do Pythagorean theorem to get that other side, but it's going to be 4. So I'm going to go with that same logic, cotangent of the angle. If I rewrite that statement, it comes out to here. And that's really all I'm doing. I'm just looking at the angle. Well, again, if you can think of cotangent, that's fine. I like to think in tangent. Tangent's opposite over adjacent, so adjacent over opposite will be my answer. So negative 4 thirds we'll answer that one.